Okay, well, good morning, everyone. My name is Mark Schmidt. I'm a business development specialist for Mobile Robotics for Omron, and I'm here today to just talk to you a bit about the technology of autonomous mobile robots. I just want to talk a little bit about Omron as a company in a glance. That number is 80 plus, is now 90 years old. We're celebrating our 90th anniversary, founded in 1933. We are a Japanese company, traded publicly on the NASDAQ, and we are a global company with 300 plus offices in 150 countries. Wherever there's industrialized nations, Omron has a presence there. Total employees globally are roughly 37,000. And a big part of our market share is in industrial automation. That's the part that we play very heavily in. Just to look at the breakout of our global footprint, automotive is big, social systems, the industrial automation. There's several verticals that we play a lot in, which is basically logistics, automotive, life sciences, digital, and aerospace. We're broken up into different groups. Here in North America, we're called Omron Automation Americas. That basically covers all of Canada, the United States, Mexico, Central and South America. We're all under one umbrella as our group. Here in the Americas, Here in the Americas, we do have offices in all those countries. Our main office, of course, our headquarters is located in Chicago, Illinois, which is in Hoffman Estates, about 20 miles west of the city. That's where we drive the Americas business out of. And today we're just going to talk about the mobile robots. We do offer fixed, several fixed, the Scaras, the Parallels, the 6-axis, collaborative robots, but today I'm going to focus mainly on mobile robotic technology. So we call the mobile robots AMRs, which is autonomous mobile robots. And basically they work the same function as AGVs, moving materials, but only they have the benefit of being collaborative. This just shows a bit of our portfolio with our mobile robot line. So we offer different size and payload capacities of mobile robots. Our smallest are 60-90, we call them LD60-90, and basically what that is the payload capacity that the robot can carry. Up from there, we offer an LD250, which is a 250 kg capacity robot. And then we jump up to a 1,500 kg, which is mainly used for logistics or moving large loads. That robot itself is roughly 48 by 67 inches long. It's got a very large footprint. In addition to that, we offer cart transporter systems to move carts about within the facility. We have our cart transporter for the smaller robots. Payload capacity is roughly 130 and 105 kg, depending on the robot you're using. And then we also have a 250 kg cart transporter solution. In fact, when you go out into the back, we have a 90 kg and a 250 kg running out there, and the 250 is a cart transporter. So you can see it up close and personal. In addition to that, we do have custom-built solutions. Really, the main one are the ones with the robotic tops on them. We call them mobile manipulators. That style has a collaborative robotic arm on it, and then we also, mainly for digital and clean room applications, mobile robot with the Scaro robotic arm. So to talk about the mobile robots, they are designed to dramatically improve the product flow within the facility. Being autonomous, they can increase your throughput, eliminate errors, and just improve the traceability of the robots out on the floor. The anatomy of a robot is basically 3 components. You have the robot itself, an application payload. It can be active or passive. When I say active, it has something on it that it needs power to operate or communication ports for it to keep track of things. and then of course your cargo. And that's very important. When we figure out the type of robot that best fits your application, we need to know what the loads are, what the profiles are. Is it a point load? Is it evenly distributed? Size of the load, the heights of it, to take into consideration center of gravity. So there's a lot of due diligence that we do when we're determining the best solution. So how does it behave? Well, the robot's very deterministic. It can work around people and other collaborative settings. With the use of the fleet manager, it will control everything the robots do out on the floor and just make sure that they're collaborating with each other and the people around them. And we like to compare them in 3 different ways. So you have your manual logistics. That's, people moving carts, lift truck operators moving materials around, but it needs human interaction. And then there's a traditional automation, which is conventional AGVs and conveyors. I like to refer to those as buses because they have to stay on defined paths. They need some kind of infrastructure like tape on the floor, wire, targets, or with conveyors, they have their lines that they transport and transfer to and on and off. And they're very restrictive in what they can do. Omron's autonomous mobile robots I refer to as taxis. Because they're autonomous, they will find their own best way to get there within the parameters and the limits that you allow the robots to run in. You just send it its instructions, tell it what goal it needs to go to, and it'll find its own best way to get there. In comparison to those transport methods, there's really 4 basic flows within a facility. You have something either going to one point and back again. Maybe it's what I call milk runs. It's just running a loop or some kind of course where it makes multiple stops along the way. It could be one pickup point to many delivery points, or many pickup points to many delivery points. So based on those flows, really the AMR is really the only product that can perform the same transport methods that humans can. So it really expands the capabilities of the robot itself. This just shows some of the workflow examples that we've deployed mobile robots in. We have warehouse solutions, mainly replenishment, put away, and order consolidation. Manufacturing solutions, pre-line, in-line, and end-of-line processes. And then, of course, inventory management processes as well.
Have you ever considered how much time employees waste just walking around? It's not unusual in a warehouse or manufacturing facility for some to spend half of their shift walking. Manual material handling can lead to fatigue or injury when a worker performs repetitive tasks. But there is an easy solution. Introducing Omron Mobile Robots, the world's smartest and most productive autonomous intelligent vehicles. No facility modifications are required, including laser beacons, floor magnets, or tapes. The navigation is based entirely on the natural features of the facility, and the robot can be set up within an hour. Omron Mobile Robots increase throughput, reduce machine dwell time, eliminate errors, improve material traceability, and allow employees to focus on tasks that require more complex human skills. They can even reduce configuration costs because the mobile robots can adjust instantly to new workflows. They're designed to work safely around people. Unlike other robots that can only follow a fixed path or aren't centrally coordinated, Omron mobile robots can detect obstacles without having to wait for a specific path to clear. They also work collaboratively in a fleet. A central fleet manager provides traffic control for vehicle routing and optimizes plant operations. Omron mobile robots are the most advanced autonomous intelligent vehicles. Their flexible design enables endless configurations. It's a safe, intelligent, and field-proven solution that's delivered new levels of productivity and efficiency in the most demanding 24/7 operations.
So to sum it up, the advantages of the mobile robots is they're very cost effective. They're economical to get started, to deploy, set up, because there's no really any major infrastructure changes. They're scalable, have a lot of customers that redeploy them in facilities based on peaks and valleys throughout their production year. So it's easy to just kind of move them to other areas. If you change some lines around or reconfigure lines, it's real easy to just go in and you scan the area where you made the changes, and you can drop that scan right into the main map without having to redo everything from the beginning. They adapt to different environments, and of course they improve your throughput capabilities. So what makes that possible to make them navigate? It's the LiDAR in the front. It's a safety laser where once the digital map is created and you set all your rules in there, the robot will use the LiDAR to compare what it's seeing versus what the map's telling it to navigate. Based on the speed it's going, of course, the laser itself is 7 inches off the floor, so it's scanning in a flat plane, the 250 degrees on the smaller ones. And depending on how fast the robot's going, that determines how far it looks out when it's moving throughout the environment. So to set it up, it's really simple. After this demonstration, we can talk about it more with the robots out on the floor. The first thing you do is you plug in what we call the teach pendant or the joystick, and you put the robot in scan mode, and you just walk the dog. It's like driving an RC car. You drive it around all the areas where this robot will probably be in service for. Once you've done your map scan, you just, with an Ethernet connection, you just plug it into the maintenance port there, showing in the middle, and you just upload the map into the software. Once the map is uploaded into the software, you go into your configuration tools where you can set your goals, your to-froms, the directions the robots have to go, the speeds they have to go, any special rules with intersections or pedestrian traffic where you want the bias left or right. Those are all kinds of things that you can just do right into the software. Once you have everything configured, just put the robot into service. This just shows an example of what you would look at on the map when the robot's operating in the environment. This robot is using a product that we offer called Acuity. It's a camera facing upward, and we map the lights of the ceiling lights. So not only is it using the LiDAR and the encoders on board to determine its direction and speed, it's also using the camera. And this is very good in areas that are very dynamic, where stuff is constantly moving. You can see those yellow boxes. Those are what we call forbidden zones. That's one of the things you set up. Those are areas where the robot could never go. And within that too, like I said, you can send your speeds, directions, and certain rules for the robot to behave at when it's operating in the environment. You can see those green lines. That's the LiDAR localizing against what it's seeing. And then those little blue dots moving around, that's the lower tow laser picking up movement below the scan plane. So as I mentioned before, on the smaller robots, 250-degree coverage, depending on the speed of the robot, determines how far it's going to look out to be collaborative around people. It also has, our larger robot has 2 of them, one in the front and rear, so that provides 360 degrees of coverage. In addition to that, the larger robot has 70 safety points. So when the robot's moving, that kind of adjusts, depending on speed, direction, and turning of the robot, just to make sure that it always has 350 degrees of coverage. If something obstructs it, it'll stop and wait for a second or two. And once that obstruction moves or is out of the way, it'll just go around it if it doesn't move. And then it'll just go about its way. In addition to the safety laser, the LiDAR, we do have a lower laser which looks for obstacles on the floor. It's not a safety laser, it's just for obstacle avoidance. And we also offer optional side lasers. Those are used in environments where there might be overhang. The main laser sees the table legs, but it's not seeing any overhang at the top of the table. Or it's going down aisles where you have machine centers and there's keyboards, or the HMIs hanging out. So it'll see those and make sure it doesn't run into anything. We use these really standard for cart transporters mostly, or any product that has overhang, where the overhang is larger than the robot. We also offer some precise performance options for the robots. I talked about acuity. It's the camera facing upward, mapping the lights. We also offer 2 products called cell alignment positioning, or CAPS, and high accuracy positioning, or HAPS. And basically what those are used for, when you have, the robots have to have high repeatability. So they have to meet really tight tolerances on their approach and positioning within plus or minus 10 millimeters. That's when these products allow the robots to have that type of repeatability over again. The cell alignment is a software upgrade. It is an option. Use that a lot for like conveyor transfers or pickup and delivery stands where it's got a tunnel under a stand and pick up from underneath. The HAPS is used more for machine interface, where it's got to go in and come out with very tight tolerance. That is basically magnetic tape on the floor with a couple HAPS sensors underneath the robot, and it locks onto the tape when it goes in and out, just to make sure it meets those tight tolerance capabilities. So what it does is it does increase the reliability of it hitting those tolerances. So the CAPS itself, basically, like I said, used for like lift stands or conveyor alignment for conveyor transfer. They're also used for the cart transporters to locate the flags on the vehicle so it knows where the cart is positioned, so it aligns and approaches and tunnels underneath without any issues. So as I mentioned before, the big difference between AGVs or tape-guided vehicles and the AMRs is no infrastructure. They're not buses, they're taxis. They're easy to set up. They navigate autonomously. They have their own built-in obstacle avoidance, easy to make map changes or pickup and delivery destination changes, and easy to scale up and down as needed. But when it's time to kind of determine where the AMRs fit well in your facility, there are some strategies that you have to take into consideration. So this isn't really a quick sale. When we do these AMR projects, the cycle or the sales cycle for these is anywhere from 6 months to 2 years, depending on the size of the fleet and the complexity of it. But a lot of things to take into consideration when you're considering that is, number one, is of course your layouts. A lot of layouts, you have narrow aisles, big aisles. You want the robot to do certain things. We have to take into consideration how well the robot can navigate those aisles. Sometimes we need them to go 2 ways, and if the aisle is too narrow, we'll have to set up 1 ways, which will affect the throughput a bit. So these are just things to take into consideration. Where your to from points are, just make sure that the robots can operate effectively within that environment. The second one, of course, Second one is smaller batches, reduced payload. I go into a lot of customer sites and they want to move carts, but the carts they're moving are 30 inches wide and 6 feet long. And they're like, well, we do that because, I don't got operators to be moving carts all day, so we bring a whole bunch of product to there. And they're thinking that we can give them a mobile robot to move that 1 cart. And a lot of times it just doesn't work just because of the size of it and the way the robot has to navigate. So just take into consideration that my suggestion is let's do smaller batches and more frequent deliveries. I mean, the robot doesn't care. We set it up so there's balance, and we'll meet your throughput requirements. They don't take breaks. They don't show up. You know, they'll show up every day. So we take that into consideration as well. Oops, keep hitting that wrong button. Next one is to reduce the uncontrolled traffic. That's the obstacles. Maybe it has to go in areas where there are a lot of pedestrian traffic, a lot of lift truck traffic. So we really need to take into consideration, not so much the robots. The robots are designed for obstacle avoidance. What we really have to look at is how well your operators are trained and how well they can work around the robots themselves. If we can get wider corridors, that's great. Like I said, two ways work better than one ways in terms of throughput, number of robots to meet your throughput objectives. Payload and footprint, we like the payload to be about the size of the robot deck. We can do longer and wider. We just have to take into consideration because it does have an impact on navigation, and we'll have to kind of configure things to make the robot think it's a little bigger than it is so it can navigate aisles and make turns. And then the last thing is proof of concept and simulation. That's something where Mechatronics can bring a robot into the customer site and run it through their environment just to make sure that the robot can easily navigate. Once a fleet size has been determined, we have the capabilities to simulate it, just to validate the fleet count and how the robot meets your throughput requirements. All our robots meet all the industry standards. EN 1525 is the big one for mobile robots, and we do have all those compliances. A lot of times customers ask for these industry standard certificates, so those are available if you need them.
That's the idea behind Omron Enterprise Manager, our industry-leading intelligent fleet management system for mobile robots. Like an air traffic controller, Enterprise Manager continuously monitors and coordinates fleets of up to 100 mobile robots in highly dynamic environments like factory floors and warehouses. But Enterprise Manager does far more than just control traffic. It actually enables robots to collaborate, to work together as a team, to solve complex challenges that robots working independently can't. Without Enterprise Manager's centralized intelligence, robots can get stuck when another robot unexpectedly blocks their way. Robots will waste time by sticking to their original order of assignments, even if that isn't the most efficient order. And when robots can't cooperate, traffic jams can occur when they arrive at the same place at the same time. Enterprise Manager can detect and resolve these conflicts. It can alert the robots to reroute or even reassign the task to a different robot, so your tasks keep moving. Enterprise Manager always sees the big picture and can even look ahead. It understands each robot's capabilities and continuously reevaluates their assignments to optimize performance and utilization. And it intelligently sequences their arrivals to avoid traffic jams. Without Enterprise Manager, your entire fleet of robots can run out of power at the same time, bringing everything to a grinding halt as they all recharge together. And updating robots with new destinations and map changes can be a tedious and time-consuming process. But Enterprise Manager minimizes downtime. It can stagger charging schedules to keep your fleet working around the clock. It can update all of your robots instantly without interrupting their operation. And because Enterprise Manager interfaces with MES and WMS software, your robots can automatically adapt to new destinations on the fly without any human intervention. Omron Enterprise Manager is the leading intelligent fleet management system for mobile robots. It's a field-proven solution from a global leader in mobile robots with over 20 years of experience and thousands of mobile robots deployed worldwide. Optimize the efficiency of your facility, maximize reliability and uptime, and increase your flexibility and agility with Omron Enterprise Manager.
So basically the Fleet Manager, it's an appliance right here. It's a black box, gets mounted in the server room, connects to your host system via an Ethernet. communicates to the robots on the floor via Wi-Fi. The onboard is the same software that's on the robot, but only it has some extra functionality. We have an integration toolkit there, along with the flow core. It just enables the robots, the fleet manager, to manage the robots through your host system, either at MES, ERP, or WMS, through standard REST, SQL, and MQTT APIs. So just to recap that, so it does intelligent job assignment. It'll queue up all the jobs being sent, determine what robot will do that based on the robot's location and the type of topper it has on it. It'll manage their motion on the floor at their destination and pickup points. You can see they're lined up. We call that taxi lining. There are several locations where same robots are going to the same point. It'll just automatically line them up to do their transfers. It'll do the traffic control so they don't run into the same paths or crash into each other. Real-time updates, map navigation, job updates are done automatically. You can go in the mobile planner and see what all the robots are doing at any time, what jobs are in queue, what jobs are done. Also provides a charge management that's very important if you run more than one shift. The robots are running 2 or 3 shifts. When we figure out what the fleet size is and the throughput, we take into consideration charge management, so every hour or 2 hours, a robot can come off and go to a charger and take a drink. The last one is skill administration. That's important as well because of the family of robots that we have. You can have different toppers. You can run 250 kg with a 1500 kg. Maybe one's got a conveyor top, one has a lifter. Fleet manager will know which robot can perform what function to make sure the right robot is assigned the job. We also offer a tablet edition. Can't run on a phone, but can run off a tablet. It can run on iOS or Android. It's a free download. Just go into iTunes and you can download it for free. And basically what it does, it provides a lot of the functionality in mobile planner that you would do on your laptop out on the floor. You can view locations, view alerts, do some troubleshooting, and also have flexible access control with accounts and passwords. So it does connect to the Enterprise Manager, so you're seeing the same thing Enterprise Manager is doing. View status, look at the map, look at alerts. If you need to take one offline and manually drive it, you can manually drive it off the tablet to wherever it needs to go. You can localize it. If it gets lost, you can relocalize it. You can send it to destinations without having either the fleet manager doing it or having a call button. You can just do that off the tablet. And then, of course, you can just view the job counts. Just to give you a little brief on the robots themselves. So I mentioned before we have a 60 and 90 kg. These robots are used for mainly light manufacturing, lab, anything where you're moving small parts, so you've got to move through small aisles. It does have a 15-hour continuous runtime, but we still like to do the opportunity charging throughout the day. And it's a pretty fast robot. It can go up to 1.8 meters per second. The size of this robot is, because everything's in metrics, it's roughly 19.5 wide by 27 by 15 inches tall. The LD, the 250, which is another robot that's out and back, it's its big brother. It's got the same sonar, LiDAR, same locations, extra E-stops. This one has metal skins. It's a little more robust. Of course, for bigger payloads. 250 kg. It's not as fast as the smaller one, but 1.2 meters per second is still a pretty brisk walk when the robot's running. This one has a continuous runtime of 13 hours. That's kind of, it's more of a passive topper. If you got it connected to a conveyor top or a lifter where it's running power off the battery, you're going to get a little less runtime, maybe 10 hours or 9 hours, depending on hours of operation. But still, like again, the fleet manager will manage charge schedules and make sure the robots are running all day. This just shows some 250 applications. Here's one where it's a conveyor top. It's just gravity fed. So it's delivering totes from the top and accepting totes from the bottom. The one on the right is a 250 cart transporter. As you can see, we've got side lasers on there. Those little tubes coming out the side, those are side lasers on the robot. So it can look beyond the footprint of the cart or the load itself. Just want to give some examples of toppers just for ideas. Cart transporter, of course. You got the vehicle, drives under the cart, latches onto it. You can configure that cart shelf, many different configurations, again, based on what the load you're moving and the profile of it. Standard tote movement, specialty carts with flat shells, and the ones on the side, obviously it's something that's stored vertically on its side with those slots. Skipped one. Conveyor tops, very popular one. We've done all kinds. Belt conveyor, front load. Side load, twin deck. This one has 2 outputs, so it just pulls up and it transfers 2 at a time. This one's got a Z-axis lift. That's for an application where the input and outputs are at different elevations, so it's got to move up and down if it's retrieving or placing. This is just a front load powered roller conveyor. This one is a twin front deck, just enough to take 2 totes deep. And this one is a side load. You can see there's only one output here. This one's got a 90-degree pop-up transfer, so it accepts, great, pops up, moves it to the back, accepts another one. Shelf carriers, pretty standard type of shelves. Totes, all kinds of materials, flat shelves, depending on what the product is you want to move. These are just passive shelves, a lot of them. Don't require any hookups to the battery for power. We do lifters. This here has got a lifting device on it where it drives into a pickup and delivery stand, and it'll rise from underneath and pick up the totes or whatever it is, and deliver them to another pickup and delivery stand and just drop them off there. Miscellaneous other toppers we've done. This one's got an extractor that pulls the rack in and out of an autoclave. Of course, during COVID, UV sanitation robots was a big deal. Robots with Z-axis lifts, interfacing with machine cells, and this one you can see, not very good, but there's tape right there where it's locked onto the tape using HAPS. So it get that real tight repeatability. Test devices, surface mount technology for printed circuit board build. Robotic arms on them. This is a lab robot with a precision arm on it, picking plates, samples, tissue samples. This one is chemical dispensing. It's a food company. The robot's just patrolling 5 times a day, spraying chlorine dioxide in all the drains in the building, just to kill any bacteria that might be lurking there. And then, of course, the mobile manipulators. Both the 90 kg and 250 kg can be designed with a collaborative arm based on the size of the arm and the reach you need. Regarding the mobile manipulator, these things are becoming more and more of interest to customers because they can do pick and place applications, light manufacturing, machine tending, just material transport, picking and placing. It kind of like, instead of having a fixed robotic arm, you've got the fixed robotic arm that can move from station to station and do multiple tasks. Regarding the HD, again, I mentioned this one because of the size. It's got 360 coverage and the 70 safety patterns that it uses when it's turning in the direction, the turn of it, and the speed that it's moving. It's got onboard safety controller, so it manages everything that's on board the robot. And of course, the system is used for large loads, a lot of times in logistics or warehouse type operations where you're moving pallets or racks, large items like that. Oops, sorry. As I mentioned before, the size of the robot, it's 47 by 67, so it's pretty large. It's got the payload of 1,500 kg or 3,500 pounds. This one has a fast charge system. The smaller robots, you get about 3 hours, 3.5 hours for the robot to charge from 10% to a full charge. This robot has a fast charge system where it can go from 10 to full in 40 minutes. Another nice thing about it too is the battery's got a very long life, 9,000 charge cycles. If you run 3 shifts a day, 6 days a week, the battery life is a little over 8 years. So it's a long battery life with this one. Runtime isn't as high, but with the fast charge, it's negligible with the robots out on the floor. Some of the features of it, like I mentioned earlier, it does have the lower tow lasers, front and rear. It's got the 2 safety lasers front and rear. The charging on this is the charging target, so when it lines up to charge, it'll just drive into it. It's got a bunch of e-stops on both sides and on the rear. It's got the LED assist lights for visibility. It's got the status indicator lights. If you look at the ones out there, depending what they're doing, that light will change colors and do different things depending on what the robot is. Again, you just set it up, create your map like you do the smaller ones, utilizing the teach pendant. It's got the optional side laser mounts, so if the vehicle does need side lasers, there's kits that you can mount them in there. And then there's the optional mount too for the Acuity. This just shows some of the types of tops that we do for the HDs. The most common ones are lifters, where the vehicle again drives into a P&D stand and it lifts it up from underneath. And then we got the powered roller conveyor, static conveyors, where the vehicle's loaded with a lift truck or some kind of overhead device. Those are really the 3 most common. The lifter is probably the biggest one that customers consider. We don't make a forked autonomous vehicle. A lot of times I'm asked, can you pick it up off the floor? No, we can't. This is a flatbed type system, so it's got to be able to tunnel underneath the rack or the pallet or the tote or the bin, whatever it is, and pick it up from underneath. So determining the fleet size, this is kind of an exercise we do. We go to your facility, do our due diligence, kind of walk through the process, find out what hurts, find out what you want to accomplish utilizing this type of technology. We'll get all that information down. We'll find out what your throughputs are, where the robots have to pick up to and from, and the kind of the routes that they're able to take. Based on that, we'll go ahead and do a fleet estimate. And we do make some assumptions here. This, for example, is a 1500 application. So it's got 4 missions, receiving, inbound, to put away staging, from put away to the picking area, from picking area to outbound staging. This isn't a warehouse, 3PL, third-party logistics. And then outbound staging to receiving inbound. So there's the 4 missions of the robot. So based on those missions and the throughputs that we were given, we went ahead and put together a fleet estimate, assuming that the robot can run at a speed of 1.3 meters per second, and availability of the robot is 85% an hour. So 15% of every hour, one robot's going to come offline and charge. This was also based on using a conveyor topper. So these transfer times, 25 seconds is a conveyor transfer. So we take that into consideration. We also take into consideration unknown factors and traffic congestion. If it's got to go in an area where there are lift trucks, it's got to work around with lift trucks, or maybe some pedestrian traffic, there's going to be instances where the robot's going to have to slow down. So we take kind of like that in there, and we come up with an estimate of a fleet. In this instance, we said 6 are needed for this application. Put together some budget pricing. It all looked good. Customer wanted to take it to the next step. So what we do is we simulate, what I mentioned before. So this is an example of how the simulation works. Based on all that information that we do, one of our robotic application engineers, they create orders, and they put those orders into the simulator. This application, we proposed 12 LD250s. So each robot is online. We're seeing here all the jobs that he created. The blue dots are the robots completing the jobs. The checked ones are complete. This with the green is robots and jobs in queue. And so we run it. We run it for a period of time. Watch how the robots react, how they can navigate the environment here. This is a DXF drawing of the actual floor plan of the facility. We can also do it off of an actual map scan if you don't have a CAD drawing of your facility. So we watch how the robots run, see if there's any problems with intersections, and there were with this one, so they did preferred lines here. You can see those 2 gray boxes. It's telling the robots to bias to the right when it's in there, to stay on a course. We call it selective autonomy. You can make the robots act like an AGV, so it can be autonomous till it gets to a certain area. If it has to act like an AGV, it will. But as an AGV, it follows a line like a bus. It doesn't stop. If there's an obstruction, it's going to wait until that obstruction's moved. Once it gets past there, it becomes autonomous again. And what it's doing, it's delivering the conveyor inputs here. This is 2 palletizing systems. Now, we didn't simulate that part. They've got 2 of our 1,500 kg robots taking built pallets from the palletizer. Each one's a 6-pallet nest, and there's 2 of them. And then taking them to the stretch wrapper, and then from the stretch wrapper to the warehouse. But this was the mission critical right here. It's making sure that these robots can take the cases from the injection mold machines on time, within the cycle, the machine cycle times, and how many cases the machine was filling an hour, and making sure it gets to the palletizing system. Once we do that, we usually provide you with some metrics. How many robots, were they always available? Were robots not available at certain times? Where were their hang-ups? What was the average speed of the robots when it was running through the simulation? Maybe it didn't match with the fleet manager, but the result of that is validate the system and let you know exactly how many you're going to need. Quickly, just want to go through some success stories. This is our own Omron factory in Shanghai. They're using it for manufacturing components. They're using just standard AMRs with a shelf top, very passive, just stacking totes on and running them between assembly processes. They're also using the mobile manipulator for some tending purposes. They've got quite a few of them running in that facility. There's a company called Intech Engineering. They're using the LD90s with a lifter, moving these cut plates in and out of machine cells. So there's one pickup and one drop-off point. The vehicles run right into the cell, into the stand there, and will pick in place. You can see here that tape on the floor. They're using HAPS in this application, and that's what the robot's mission is. I think they have 11 of them, 10 of them, 11 of them in service. This is Europa Systems. This company manufactures hearing aids, and this is their distribution center where they do the order picking and the order packing. So they're just using the smaller robots that can handle a tote, and the robots just go and with the pickers, and they pick the orders and then send them to packing stations for shipping out. This company is Scuda Automotive. They're automotive component manufacturer. These robots, they're cart transporters. They're moving parts between CNC machine cells, but they also have to collaborate with autonomous forklifts that are on the floor. So they can collaborate with other technologies on the floor. And they're using those to just kind of move them through the manufacturing process. They drop off the cart, move on to their next mission. And this is Crestech. This is a plumbing supplier. They're using this for order fulfillment. So they've got twin deck robots. That was one of the ones I showed earlier. They got the two outputs here. So the robots line up, accept totes with picked orders in them, and they take them off to packaging.